Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. We are doing chemical properties of amines and we will start with the reaction with acids. So amines, being basic in nature, will react with acids to form salts. So with any acid, amine will form the respective salts. For example, methylamine reacts with hydrochloric acid to form methyl ammonium hydrochloride, methylamine hydrochloride, or methyl ammonium chloride. Similarly, secondary amine with sulfuric acid will form dimethyl ammonium sulfate, and aniline with hydrogen chloride will form aniline hydrochloride. The salts of amines are ionic compounds and are soluble in water. On treatment with aqueous NaOH, these salts can give back the amines. The amine salts are non-volatile solids and generally decompose before their melting points are reached. They are soluble in water but insoluble in non-polar solvents such as benzene, ether, chloroform. So this difference in solubility behavior of amines and their salts is often used to detect amines and separate them from other non-basic impurities. The amines react with chloroplatinic acids H2PtCl6 to form insoluble salts called chloroplatinates. So amine will react with chloroplatinic acid to form amine chloroplatinates. These salts are used for determination of equivalent and molecular masses of amines. Reaction of amines with transition metal ions. So amines, because they have a lone pair of electrons on nitrogen atom, can donate their electrons to the D block metal ions and form a coordinate bond. So they form a complex. For example, with silver they will form dimethylamine silver chloride. With copper sulfate they will form tetramethylamine copper sulfate. These are coordination complexes. Reaction with alkyl halides. It's also called alkylation. So an amine having a lone pair of electrons on the nitrogen atom acts as a nucleophile and can combine with the alkyl part of the alkyl halide. So when alkyl halide is made to react with amine, dialkyl ammonium salt is formed, which in presence of base will give off HX to form secondary amine. Similarly, secondary amine will react with alkyl halide to form again ammonium salt, which in presence of base will give off HX and form tertiary amine. Tertiary amine can further act as a nucleophile and react with alkyl halide to form a quaternary ammonium salt. So primary amine, when reacts with alkyl iodide, will give off HI and form secondary amine. Again with alkyl halide it will form tertiary amine. Again with alkyl halide it will form tetraalkyl ammonium iodide. Similarly, methylamine with methyl chloride will form dimethylamine. With another molecule of methyl chloride will form trimethylamine. Another molecule of methyl chloride will form tetramethyl ammonium chloride. The process of converting an amine, primary, secondary or tertiary, into its quaternary ammonium salt on treatment with excess of alkyl halides is called exhaustic alkylation. Aromatic amines also undergo similar reactions. So on reaction with methyl iodide, aniline will form N-methyl aniline. On reaction with another molecule of methyl iodide, N dimethyl aniline will be formed. Another methyl iodide and trimethyl anilinium iodide will be formed. The tetramethyl ammonium salt on reaction with moist silver oxide will form tetramethyl ammonium alcohol. This on heating gives us of methyl alcohol and forms tertiary amine. If one of the alkyl group of the salt is a group other than methyl, that is greater than methyl, it will give a tertiary amine and alkene along with water on heating. For example, this trimethyl ethyl ammonium hydroxide on heating will form trimethylamine, ethene and water. Acylation, reaction with acid chloride and acid anhydrides. Aliphatic and aromatic primary and secondary amines which contain replaceable hydrogen atoms will react with acid chloride or acid anhydride or ester to form substituted amides. And this process of introducing an acyl group into a molecule is called acylation. So it is a nucleophilic substitution reaction. The H is substituted with COCl in presence of a base. So when primary amine reacts with acyl halide, the H and Cl will combine in the presence of base and RNHCOR. Substituted amide will be formed. The base should be stronger than amine, like pyridine, because it will remove the HCl so formed and shift this reaction to the right. So with the acid anhydride also, a substituted amide will be formed when reacted in presence of base, and along with it an acid will be formed. For example, methylamine reacts with acetyl chloride to form N-methyl ethanamide and HCl. So reaction occurs as, because the carbonyl group is electron withdrawing in nature, electrons are pulled to oxygen, the lone pair of electrons attack and a bond is formed. So C2H5, N, H, H, C, CH3, COCl. Then the oxygen, electrons on oxygen move back and H is given off to form C2H5NHCO, CH3. This H which is given off reacts with the Cl, which is the leaving group, to form HCl. During the reaction, the acid generated can form salt of the amine, which will then lose its nucleophilic character, and therefore reaction will not go to completion. So we add a base so that it can neutralize the acid formed and remove the HCl. Amongst the acid derivatives, the acid chlorides are stronger acylating agents than anhydrides and esters. Since tertiary amines do not contain replaceable hydrogen atom, so they will not react with acetyl chloride. Therefore, in acylation reaction, in addition to the nucleophilic nature of amines, the presence of hydrogen atom or nitrogen atom is also necessary. Acylation can also take place with acetic anhydride. So one H will move with the COCH3 part to form acid, other COCH3 gets attached in its place to form N-ethyl ethanamide. Similarly, with aniline, HCl will be formed in presence of pyridine and COCH3 gets attached here to form N-phenyl ethanamide. With the aniline, N-phenyl ethanamide is formed. HCl combines, this gets attached to form N-phenyl ethanamide or acetanilide. The reaction can also occur with acid anhydride. N-phenyl ethanamide is formed and acetic acid is formed. Benzoylation. Aliphatic and aromatic amines react with benzoyl chloride in presence of a base such as pyridine or aqueous NuH to form benzoyl derivatives, and this C6H5CO group is introduced to the aniline group. So this reaction is called benzoylation. So H and Cl combine to form HCl, and COC6H5 gets attached on the NH to form N-ethyl benzamide. Benzoylation of compounds containing active hydrogen such as alcohols, phenols or amines with benzoyl chloride in presence of dilute aqueous NaOH solution is called Schotten-Baumann reaction. So not only aniline but phenols also can react with benzoyl chloride in presence of base. The reaction will be called Schotten-Baumann reaction. Schiff's base formation, reaction with aldehydes and ketones. Aldehydes react with primary amines. The oxygen of aldehyde and 2 hydrogens of amines will combine to form water, and addition product is formed which is called Schiff's base or anil. The acetaldehyde will combine with ethylamine to form ethylidene, ethylamine, Schiff's base and water. Aniline will react with benzaldehyde. Again, water will be removed and these two combine to form benzyl aniline or benzylidene aniline. It's also a Schiff's base. The Schiff's base on reduction will give secondary amine. This method can be used to prepare secondary amines. Aldehydes and ketones which have alpha hydrogen react with secondary amines, both cyclic as well as acyclic, to form carbinola amines. So this is a ketone which reacts with secondary amine in presence of benzene and para-toluene sulfonate, PTS. So this H oxygen electron move here, H goes there, the rest of the R2N gets attached to form this intermediate on from which this H and OH combines to form water, and alpha beta unsaturated compound is formed. Similarly, ketone will react with secondary amine in presence of benzene and para-toluene sulfonic acid to form an unstable product which will later on lose water molecule to form a double bonded tertiary amine, N-dimethyl-prop-1-ene 2-amine. So products formed are enamine, a double bond along with amine group. It may be noted that equilibrium shifts in the right because the water that is formed in the reaction is removed with the help of benzene as azeotropic mixture. Thus, enamine formation is usually carried out by refluxing the benzene solution of aldehyde or ketone with secondary amine in presence of trace amount of acid such as para-toluene sulfonic acid. The enamines can also be reduced with catalytic hydrogenation. 1H goes here, 1H here to form N-dialkyl amines. N-dimethyl 2-propene-amine in this case. Reaction with chloroform, carbide amine reaction or isocyanide test. Primary amines react with chloroform and alcoholic QH to form isocyanide, which is a bad smelling product, along with KCl and water. Reaction occurs in this manner. The 3 molecules of HCl will be formed and the N combines with C to form isocyanide. The 3 HCl will combine with QH to form KCl and water. Reaction with nitrous acid. Nitrous acid is an unstable product compound, so it is prepared in situ by reaction between sodium nitrite and HCl in cold conditions. So hydrochloric acid taken is cold and dilute. The nitrous acid is a source of electrophilic nitrosonium ion, so it can react with amines. So different classes of amine react with nitrous acids differently. Primary amines will react with nitrous acid to form aliphatic disonium salt, which is unstable and decomposes to give alcohol and evolve nitrogen. So this RNH2 plus HNO2 will form RN2 and Cl negative, alkyl aliphatic disonium chloride. This will, in presence of water, form alcohol, and nitrogen is given off and HCl is formed. We can also write this reaction as C2H5NH2 plus HONO, N and N combine to form nitrogen, OH combines with C2H5 to form alcohol, and H2 combines with oxygen to form water. Primary aromatic amine will react with nitrous acid in the cold 273 to 278 Kelvin to form benzene disonium chloride. But if the temperature is greater than 278 Kelvin, then this disonium chloride will decompose to form phenol and nitrogen and water. Secondary amines. Secondary aliphatic amines and aromatic amines will react with nitrous acid slowly in the cold to form yellow oily nitrosoamines. So H of secondary amine and OH of nitrous acid will react in this case to form water, and NO gets attached to form nitrosoamine. Similarly, diethylamine will react with nitrous acid to form NN diethyl nitrosoamine and water. N-methyl-aniline, a secondary amine, will react with nitrous acid to form N-nitroso N-methyl-aniline. The yellow oily liquid gives green color when warmed with phenol and concentrated sulfuric acid. And on dilution with water, the color will change to red. And it will again change to greenish blue to violet on addition of base, sodium hydroxide. So the overall reaction is called Lieberman-Nitroso reaction and is used as a test for secondary amines. So yellow oil turns green when warmed with phenol and sulfuric acid, turns red when water is added, and again turns greenish blue to violet when NaOH is added. Test is Lieberman's nitroso test. Tertiary amines will dissolve in cold nitrous conditions to form salts which decompose on warming to nitrosamine and alcohol. So the salt formed will be nitrite salt, alkyl ammonium nitrite. On warming, the alcohol, one of the R will move as alcohol and 2R will be left with nitrogen and NO. This is nitrosoamine. For example, triethylamine on reaction with nitrous acid will form triethyl ammonium nitrite. Aromatic tertiary amines react with nitrous acid to give colored substituted nitro compounds. These undergo electrophilic substitution of nitrosonium ion at the para position of the phenyl ring. So dimethyl-aniline on reaction with nitrous acid will form para-nitroso N-dimethyl-aniline. This N-nitroso dimethyl amine is a powerful carcinogen causing cancer. It's very harmful. It is present in the smoke of cigarette. So cigarette smoking is harmful to health. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.